Greetings, amazing scholars. I'm here to help you with number 8 on your Module 2 homework. It looks like we're dealing with finding the probability of particular outcomes of playing a game called Angry Bird. And our players are Bob, Fran, and Julio. It looks like Bob only needs to win one more round to win the overall game, and Fran and Julio each need to win 2 more rounds to be the overall winners. So it looks like we have a game going. Let's go ahead and pull up this PowerPoint I kind of put together real quick here. So we have 3 players, Bob, Julio, and Fran. And I don't know what Angry Birds is. I'm just going to think of rolling a die. They're each going to roll a die, and whoever gets the highest number is the winner. That's really what it boils down to, all we need to know about the game. So Bob only needs to roll the highest one time. So what does that mean? That means, whoops, set this up all right, so that means that Bob has 1/3 of a chance of winning. Oh, now what? All right, Bob has 1/3 of a chance of winning. Julio has 1/3 of a chance of winning, and Fran has 1/3 of a chance of winning if it's just whoever rolls the highest die. So just think about it like that for just a second. So that would be if they were each equally likely to win. But in this case, it says that Fran might cheat. Well, if Fran were to cheat, by giving herself a 5 times as likely of a chance to win any individual match. So now Fran says, okay, I'm cheating and I'm 5 times more likely to win. Well, now instead of each being equal, Fran has 5 shots at winning. So that's 5, 6, 7. So now Bob only has a 1 in 7 chance of winning. Is that going to change my whole fraction? Come on. A 1 in 7 chance of winning. So that means that each of these is 1 in 7 except Fran. Fran is now 5 and 7, right? Fran has 5 out of those 7 chances of winning. Some of you have a question that says Fran increases her likelihood of winning each round by 3. Well, in that case, you just have 3 of these pieces for Fran, and so your denominator changes 3 for Fran and 3, 4, 5. So it would be 1/5, 1/5, and Fran would be 3/5. So that's how your denominator is changing, which seems to be the question I'm getting the most of. Now let's look at building this tree. Part A here is asking us to build a tree. And what we're going to do is, the final question here is to answer, is Fran giving herself enough of a likelihood of winning by cheating on each individual round to affect her likelihood of winning the final outcome? So that's what we're going to calculate over here on Excel. So first of all, we have Bob. I'm just going to put my 3 letters up here. Bob, Fran, and Julio. Now, what happens if Bob wins? Well, if Bob wins, it's over. He only needs to win 1 more round. So if Bob wins, we're good. But if Fran wins, then what? Fran wins 1 round. Well, she still needs to win 2 rounds. So if Fran wins the next round, then we're going to have, in our next column, Bob's going to be the winner, or Fran or Julio. You see that? So if Bob wins, there's no more columns. If Fran wins, then we have a next column that Bob, Fran, or Julio can win. If Julio wins, well then Bob, Fran, or Julio can win the next round. All right? Now, do we have a 3rd round? Well, in some cases we do. If Fran wins this one, I know I'm saying this one, but if Fran wins the first round and then Bob wins the second round, then it's over. If Fran wins the first round and Fran wins the second round, it's over. If Fran wins the first round and Julio wins the second round, then we have 3 options that could happen on the 3rd round. Bob, Fran, or Julio. And then coming down here, if Julio wins the first round and then Bob wins the second round, it's over. If Julio wins and then Fran wins, then Bob, Fran, or Julio could win. And then if Julio wins the first round and Julio wins the second round, it's over. So if you guys understand that, that's a tree diagram. And all you have to do is view the example for this problem, and it will show you a tree diagram that looks more intuitive than mine, because mine's on Facebook. I'm sorry, because mine's on Excel. It doesn't look as good, but it's the same thing. All right, guys, I'm ready to start rolling forward here. We are going to check the probability of these outcomes. First of all, I'm going to go ahead and record some stuff here. The winner is, in this case, the winner was Bob. What happened in this row? Well, look at my tree diagram. I had Fran and then Bob. You see that line? Here it is right here. Fran and then Bob. So here I have Fran, Bob. Here I have Fran, Fran, Bob, Fran, Julio, Bob. You guys got that? And what's this? Fran, Julio, Julio. Look, I said Julio and spelled it the English sound H instead of the Spanish sound Julio. I know some of you are probably wondering where that H came from. Hopefully you were able to figure that out. Little things like that are important to not ever say, I felt so confused, but to say, I think this might be why. So you guys should work on trying not to say, I felt so confused, but always try to do problem solving. All right, so here I have Julio, Bob, Julio, Fran, Bob. And if you guys can't keep up with how I'm getting this tree in Excel, then just look over here at the lovely example that Dave Sebecki and Brian Mercer put together for you guys. Here I have Julio, Fran, Fran, and Julio, Fran, Julio, and Julio, Julio. All right, so now what I need to do is calculate, well, I guess I want to know who's the winner here. In this case, the winner is Bob, Bob. Anywhere I see a B, so I have a mistake right here, don't I? This one didn't make sense to me right now because I'm not going to have Fran, Fran, Bob because that would make them both winners and we're not going to have a tie. So if we were going to assume a tie, that would change all of this tree would be much more entailed. So let's just see where I made that mistake. It was Fran, Julio, Bob. You see that? Fran. Okay, so I have a little mistake here. This was Fran, Julio, Bob, and this is Fran, Julio, Fran. Fran, Julio, 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 Bob, Julio, Fran, Bob, Julio. All right, looks like I got it. All right, so in this case, again, Bob is the winner. Everywhere I see Bob, he's going to be the winner. So I'll just kind of get rid of those. All right, now I have Fran's a winner. Fran, Fran, and then Julio's a winner. All right, so now I can see who the winners are. Now I'm going to make myself a little chart over here. First of all, I have probabilities of each of these things occurring. I want to know the probability of Bob being the winner. We'll even do it like they did. Probability of Bob winning, the probability of Fran, and the probability of Julio, each being the winner. We know that the first probability is going to be 1/3. Well, it would be 1/3 if they each had an equally likely chance, but Fran's cheating. Remember, we're going to calculate it as though she's cheating. We can't say she's cheating. All right, so here I'm going to put in my 1/5. And it gives me a decimal value. Guys, we should know by now, I'm going to select these cells, come over here, change it to fraction. And even fraction's not going to be enough. So I'm going to go to more format, just in case, go down to fraction, and give it up to 3 digits. I just like to have all my digits like that. All right, so the probability of Fran, remember Fran was cheating. I'm sorry, I said 1/5. It was 1/7. The probability of Fran was 5/7. And the probability of Julio was 1/7. All right, so now I've got to calculate some stuff. I think they're asking me to calculate the outcome of each of these occurrences. So let's see. Back to my actual question here. The question is asking me, oh, what's my sample space? Well, I just did that. It goes from B, it's Bob, Fran, Fran. So Bob, Fran, Fran. It looks like it's going to be Charlie here. You see it? All right. Uh-oh. Oh, maybe it was Alpha. They were awful similar. All right, so the next thing I'm going to do is calculate the probability of each of these occurrences. Well, the probability that just Bob wins is, well, this is exactly what we see right here, 1/7. So I'm just going to put an equals 1/7 in there. And it's just asking me for each of these probabilities. So I'm going to make my Excel big. All right, so the probability of just Bob winning is 1/7. And you guys can see when you check in your example here, and it gives it to you right here in the actual question. You're going to use the multiplication rule. It's the probability of alpha and the probability of Bravo. Well, I'm sorry, right. In this case, we're just using variables. So look at here. We have the probability of Fran times the probability of Bob. So that's what's going to go in here is the product of that. And when we have 3 of them, it's going to be the product of Fran times Julio times Bob. So this is what this is going to look like. This one is the probability. I'm calculating these, you guys. I'll highlight them for you. All right. Put a border around that. Do I get a border? Easy border here. I don't have this Excel all set up like I always do. All right, so it's not a dark border, but it gives us something there. All right, so now I see the probability of Fran and Bob. So I put an equal sign. It's the probability of Fran, so I'm selecting Fran's probability over here, times the probability of Bob, which is right here. All right, so here I have the probability of Fran times the probability of Fran. And you guys, I'm kind of going fast because, you know, you're Excel people now. So just doing Fran times Fran. This is going to be Fran times Julio times Bob. So this is going to be Fran times Julio times Bob. Fran, Julio, Fran. Fran times Julio times Fran. And I'm going to pause the video and finish this out. All right, so I just finished that out just with using the same pattern that I had been doing. And then you guys would enter all this. I'm going to go ahead and just click solve it just to show you guys. And now you can see I have all of my matching. I wish I had it in a nice table like that. But I have the probability of Bob was 1/7. And the probability of just look down, you can see 5/49, 25/49. You can just see that each of my numbers match here. All right, so you guys will have those to enter in. Now, the next part of the question is asking us for the probability of each particular person winning. So now I want to know, sorry. Well, I don't know where the question has gone, but we'll just do it from here. So here, if I want to know the probability of Bob winning, let me just see if it's here. Nope. Oh, it's because it timed out. All right, so that's okay. Now I do not have the option to go back. So here we are going to see the probability of Bob winning is going to be all of Bob's probabilities added up together. So, sorry, this is such a mess, you guys. I'm going to have the probability of Bob winning, Fran winning, and Julio winning. So the probability of Bob winning are all Bob's wins added up together. So Bob's wins are, I can just select these Bob, Bob. Wait a minute. All you do here is press, sum, double click, and then you just start adding them up. Bob, comma, just click on each Bob and put a comma. And then enter. All right, what are Fran's probabilities? So equals sum. And then you just click on Fran's wins, putting a comma between each of Fran's wins. She only has 3. And then we do the same thing for Julio's wins. Looks like I got an N in Julio's name. Julio's wins. There we go. All right. I am going to assume that this number is too big for that cell. And I'm going to stretch it out just to see if that's the problem. And that is not the problem. Oh, I did not put sum. You see that, you guys? All right. So there we have all of our answers. So these are going to be the final answers for that particular question. I'm going to go ahead and stop this and see if I can answer another one for you guys.